Okay, are we okay with this one? It's a little tricky. Which method do you prefer? Any favorites? I like the one where I find my exterior and then I just do it that way. That's the one I like. So I'll just do that one for now. I will immediately, if I have my interior, I can find the exterior. I'm just going to go 180 minus 175.2, and I get 4.8 degrees. So think about it, like 180, this is 180, right? 175, like if you zoom into a corner, it's not a whole lot. It's probably like this, right? So that polygon is like, has a really big interior angle, right? And it's just 4.8 out here. That's what you just found. And then it's 4.8 is equal to 360 over n. You put a 1, it's 360 times 1 divided by 4.8 and is equal to 75. So 75 sides, right? Please don't guess. Okay, so this is one method. If you prefer the other one, where you actually use the interior angle formula, you go for it. But I want you to know that interior and exterior, if I give you the interior or exterior, I'm really giving you everything, okay? All right. Next. What about this one? That's the one? Okay. I actually like this one. I haven't talked about names yet, but pentagon, n is equal to 5, right? 5 sides. I will talk about names today. And so you've got 4 already. It says determine the angle of the 5th. So you kind of want to imagine, it's not really a really good 5-sided, but it's not regular. We know that. It's kind of off, right? But they give us the 4 angles here. We want the 5th. So can we use this formula to figure out what the sum is? Yes. So we know that it has 5 sides because pentagon tells us that. So it's 5 minus 2 times 180. That's 3 times 180. We know that that is the sum, right? The sum of interior angles of that pentagon should be 540 degrees. So for A, to figure out the 5th angle, we just go 540 minus, we start taking away. It's like the triangle property that we've used before, except for this is a pentagon, right? And so that ends up being 134 degrees. B is asking determine the value of each exterior angle in this polygon right here. Let's do that. Every single, I'm going to use a red pen for this one. Every single corner has an exterior angle. Right? There's 5 exterior angles that are formed. This is not drawn to scale. This is probably way off. Okay, I'm just letting you know. That's what it's asking. There's exterior angles all around this pentagon. So if you looked at my key, you already know how this is going to go. This is what I've done. I've listed all of my interior angles as given by the question. And the last one is 134. And then I'm going to just list all of the exterior angles right underneath. I can't use this one. You just cannot use this one because this is not a regular polygon, right? Every exterior angle is slightly different. So you can't use this one here. Not regular. So I would say make sure you have that emphasized. So what do these two always add up to? Interior and exterior, they always add up to 180, right? So this is 80, this is 78, this is 81, this is 75, and the last one is 46 degrees. Okay? They have a sum of 180 degrees, right? Sum of a straight angle is always equal to 180 degrees. So this is what the question was after, and now you've listed them all. Okay, so does that make sense? Dollars and cents. Next, how do you do this one? You need to figure out what the sum is. That's why S is so important, right? You need to figure out how many sides do we have. So let's figure out how many sides. That's how it always starts with polygons. 1, 2, 3, 4, 5, 6. N is 6. What's the sum of 6? It would be 6 minus 2 times 180. That's 4 times 180. That is 720. So this would be the start of your operation here. So we know that. Where do you want to start? Let's start with this one right here. X plus 20, right? Plus x plus 40. And if you did the homework, you're just sitting and relaxing, right? You're trying to find my mistakes. Right? So you just add up all the angles. How many do we have? 1, 2, 3, 4, 5, 6, right? 6 sides, 6 angles. That is going to be equal to 720 degrees as determined by this formula right here. And because all of the brackets have a plus in front of it, we don't have to really worry about distributing. So I'm just going to highlight all of the x's here. 1, 2, 3, 4, 5, 6. There are 6 of them. So it's 6x plus, that's 60, 120, 200, 300. And that is equal to 720. Let's bring the numbers over to the other side. The constants, I should say. Divide both sides by 6. And x is 70 degrees. Boom. So you probably noticed that pattern. This is basically to check do you know how to do algebraic operations? Do you know how to relate the property we've learned to get you started here? This one? I go minus 300 on this side to get rid of this, and I must do the same thing to this side. So you subtract 300 from both sides. No, we're subtracting, we're not dividing. So if you were dividing here, then this positive divided by negative would be a negative, yeah. But you're subtracting, so. All right. Let's go over to 38. Any other questions? Which one? This one? Okay. I like that one. I was hoping. So this one here, question 4, is basically just, do you know how to use formulas, right? Find the measure of all those angles. And we're assuming they're regular. Next, determine the value of the unknown values. Again, guys, listen to this part. Start with the number of sides, okay? So 1, I already said it's 9, right? I gave it away yesterday. You're welcome. Let's start with y. That's an interior angle. Angle y is n minus 2 times 180 divided by n. So that would be 9 minus 2 times 180 divided by 9. That's 7 times 180 divided by 9. And that gives us 140 degrees, okay? Y is taken care of. That's an interior angle. Interior angle. And now, how about we do Z? What would work with, could we use the formula 360 divided by n? Can we use that? It's a regular polygon. We go under the assumption that it is a regular polygon. And so we could use this, or we could use that Z. Why do I do this all the time? I'll subtract y from it, right? So you could use either one, okay? So I'm going to use Z is equal to 180 minus 140, and it is 40 degrees. So you've got Z taken care of. So I first do everything kind of on the outskirts, and then I'm going to move in. X is what? X appears to be a central angle, but it's not. It has two central angles that make up X. So let's find a central angle because we're going to need it for all of these guys here. So central angle is 360 divided by 9, and that is 40 degrees. So this is important to us. Now we're going to go angle X is 2 times 40. That's 80 degrees. Angle M, how would we do angle M? How many centrals are there? 1, right? 1, 2, 3 make up M. So that's 120. Let's do N differently, okay? I know how many slices are there? 1, 2, 3. So it's 1, 2, 3, 4. How else could we find N? Think of a circle. It's 360 all around, right? 360 minus 80 minus 120. Circle, right? Full circle. And that would be 160, right? Oops, you can't see that. There we go. But you could have also gone 4 times 40. That's also 160. So no matter how you do it, you should get the right answer. I just want you to be prepared for that. All right. Before I continue, I just want to highlight, most of you will already know this. It's a bit of a review, but we're going to go back to triangles a little bit. I just want to emphasize something that's going to be very, very handy for us. So let me just, first of all, 35. 35. This table here. For the first 12 or so, we have names for all of our polygons. Okay, so I'm going to focus on the prefixes. So we have triangle. We have quadrilaterals. So 3 sides, 4 sides. Then we've got pentagon. Then it's hexa, yeah. Hexagon. That's 6. Anybody know the next one? Septa. It's hepta. Nice try. I'm just going to stick with the prefixes, okay? You know it's gone after, right? Octa. Nona. Anybody know 10? Deca. Yeah. There we go. If I ever lose my memory, I just need some of you in my classes. Deca, and then 11 we don't have a name for. I don't know what happened. Maybe it was Friday at 5, and they're like, Deca, we're done. And then they came back on Monday. It's like, let's just do the 12, right? Dodeca. So 10, 12. Sum of interior angles. What is it for a triangle? It's 180. Quadrilateral. 4 sides is 360. Pentagon, anybody remember? We've done it today. 540. Hexagon, we also did it today. 720. And that's when it gets uglier. Hepta, no, hepta is still good. 900. 1080. I don't want you to memorize these or put them, like, just have the formulas, okay? I just use my formula to figure this out. Nona is 1260. Deca is 1440. And dodeca is 1800. Okay, so I just want you to have that, the first couple there.
For 11.
What's that?
Total for 11.
11 we don't have a name for. But I could ask you for it, but I don't have a name for it. So
What would be its total?
what would be its total?
Yeah.
You go n minus 2, so n minus 2 times 180. 1620. Yeah. All right, so that's that. I'm going to leave this up to you. If you want to fill this in, interior angle, you know the formula. Exterior, you know the formula. Central, you know the formula, right? I think this is good enough. I just need you to have, if you think you're not going to remember the number of sides and the names, because sometimes I'll just give you hepta, and I expect you to know that it's 7. So if you think you're going to remember, don't put it on your study sheet. But if you think you're going to need it, please do so. Let's go back to page 26 as well. So it's just relevant information. 26, yes. I should have done this right at the beginning, to be honest. But scalene, isosceles, and equilateral are the 3 types of triangles. Scalene, all angles are different, and all sides are different. 26. Isosceles has 2 congruent angles and 2 congruent sides. No surprises there, but this is what I want you to remember, okay? With isosceles, if I give you one angle, you can find the rest. That's the saying, right? If I give you an isosceles and you know one, you actually know them all. And here's what I mean by that. If you have 72 here, what you need to focus on is the sides, right? If these 2 sides will have angles that are exactly the same across from them. So if this is 72, then this is also 72. Boom, you got that. And angle Y is 180 minus 2 times 72. That's 144, right? That is 36 degrees. So that's one scenario that you can encounter. What about this one? You know it's an isosceles because of the markings. So we know that angle E, this one, it measures the same as the angle across from that one. So the only angle that we're given is 50 here. So what are you going to do here? Angle E is the same thing as angle F. You don't have to do this notation. You could just stick with one or the other. But it's going to be 180 minus 50 divided by 2. Because you split. You take the 50 away from 180 and then you split it equally amongst the 2 that remain. Okay, so angle E or angle F is 130 divided by 2, and that is 65 degrees. Okay, so you know this is 65, and that is 65. Okay. Equilateral, all angles are congruent. This is the symbol for congruent, and all sides are congruent. What do we know about each interior angle? It's 60, right? So there's not much to calculate. So isosceles is basically the one to focus on here. Okay? Any more questions before?